Hello and welcome to part 2 of the composition of functions series. In this section, we're going to talk about the domain of a composite function and the components of a composite function. In your guided notes, you can join us on page 3. We're about midway down the page, right where we left off from the last section. First thing you'll see is a summary of the steps for finding the domain of a function composition. If we're given f of g of x, remember we can write that f of g of x. G of x is the inside function. F of x is the outside function that we're putting g into. To determine the domain, first we're going to find the domain of g. And remember, g is your inside function. And then we're going to determine the domain of our outside function, f. The reason I'm writing inside and outside function is because do we always have to have f of x and g of x? No, we could have p of x, we could have k of x. So think about the inside and the outside function. So after that, what we're going to do is we're going to find those inputs x in the domain of g for which g of x is in the domain of f. Exclude any inputs x for which g of x is not in the domain of f. The resulting set is the domain of the composed function. So what I'm going to do is I'm going to find the domain of our inside function, find the domain of our outside function. Whatever I have to exclude from that domain of the outside function, I'm going to set my inside function equal to it. And it'll make more sense as I show you in an example. So our first example is we're going to suppose that f of x equals x squared plus 2x minus 5, and g of x is equal to 3x minus 1. And first thing we need to do is find f of g of x. So let's do that. We have f of g of x. So we're taking our function f, and anywhere where we see an x in it, we're going to put 3x plus 1. So ready? We have 3x plus 1 squared plus 2 times 3x plus 1 minus 5. And we can expand this. 3x plus 1 squared is 9x squared plus 6x plus 1 plus 6x from over here plus 2 minus 5. And then finally, we'll get 9x squared plus 12x minus 2. So that is what f of g of x is equal to. Now our rules tell us to find the domain of the inside function. That's g of x. So I'm going to circle g of x and state the domain. The domain of g of x is all real numbers. If you have anything linear, the domain is going to be all real numbers. And then we find the domain of f of x. That's also all real numbers. Since there are no exclusions in the domain of g of x or the domain of f of x, the domain of f of g of x will also be all real numbers. So our final answer for part A is all real numbers. Now we'll complete part B by finding g of f. To find g of f, we are going to take our function 3x plus 1 equals g of x, and any time that we see an x, we're going to replace it with x squared plus 2x minus 5, which is what f of x represents. So let's go ahead and do that. So we have 3 times x squared plus 2x minus 5, and then plus 1. And we can distribute that 3, so we get 3x squared plus 6x minus 15 plus 1. And finally, we'll have 3x squared plus 6x minus 14, and that's what g of f is equal to. Now we need to find the domain of g of f. Fortunately, we already know the domain of g of x and f of x separately. F of x is our inside function, and it has a domain of all real numbers. G of x is our outside function. It also has a domain of all real numbers. Since neither the inside or outside function have any restrictions, the domain of g of f of x will be all real numbers. These are both examples where neither function has any restrictions, but that is not always the case. Let's look at another example. Here we have to find the domain of f of g of x if f of x is 1 divided by x plus 4 and g of x is 4 divided by x minus 3. We can actually do this without even finding the function f of g of x, but I'm going to find the function just to kind of show you how to do it if that's okay with you. So we're finding f of g of x. So that means anywhere in the function f of x that we see in x, we're going to replace it with 4 over x minus 3. And you'll see why I wanted to go through this one. We have 1 over 4 over x minus 3 plus 4. And you can see here, this looks like a complex fraction. We don't want a complex fraction, so I'm going to show you how to get rid of that because you'll probably encounter problems like this in your homework. So we have a denominator here that I want to get rid of. So what I'm going to do is I'm going to multiply both the numerator of the big fraction and the denominator of the big fraction by x minus 3. And what that does is it's going to take the numerator, 1 times x minus 3 is x minus 3, and then we're going to distribute this x minus 3 to each part of the lower part of the fraction. So on 4 over x minus 3, the x minus 3's will divide out and you'll just be left with 4. And then here we'll do 4 times x and 4 times negative 3. So we end up with f of g of x is equal to x minus 3 over 4x minus 1. So while the problem's not specifically asking us to do the composition of functions, I wanted to make sure that we know how to do it. So now what we need to do is we need to find the domain of our inside function, g of x. So the domain of g of x, well, it's a rational function, so we know the denominator can't be equal to 0. So that means x minus 3 can't be 0, or x cannot be 3. So that's our restriction on the domain for g of x. Now, for f of x, our outside function, we know that that's also a rational function. And the domain is going to have a restriction where that denominator can't be 0. So that means x plus 4. X plus 4 cannot be 0. Or x cannot be negative 4. So what are we going to do with this negative 4 from the outside function? Because remember, we're not putting x's into f of x. We're putting g of x's into f of x. So that means that g of x can't be equal to negative 4. So I'm going to go ahead and I'm going to set my inside function, g of x, equal to negative 4. So we'll have negative 4 equals 4 over x minus 3. And we're going to solve for x. We will multiply both parts by x minus 3. I wrote over 1 because we have a fraction on that side. The x minus 3's will divide out there. And we'll get, this is times, negative 4 x plus 12. We'll subtract 12 from each side. And we'll get negative 4x equals negative 8. That tells me that x is equal to negative 8 over negative 4, which is 2. So I circled from the domain of g, x can't be 3. From setting our function g of x equal to negative 4, which is the restriction on the domain of f of x, we get x is 2. So our domain for f of g of x are all x values in the real numbers where x is not 2 and x is not 3. We can also write that in interval notation. As you can see here, we have our answers in both interval notation and set notation. In our next example, we're going to find the domain of f of g of x, where f of x is 2 over x minus 2, and g of x is the square root of x plus 4. It does not ask us to find the composition of functions in this case, just the domain. So let's go ahead and find the domain of our inside function, which is g of x in this case, right? Function g of x. And our domain of g of x, we know that is a radical function, and we know underneath a radical, whatever's under there has to be greater than or equal to 0. So we're going to solve the inequality. X plus 4 is greater than or equal to 0 by subtracting 4 from each side. And we'll get x is greater than or equal to negative 4. All right, now let's find our domain of f of x, our outside function. That's a rational function. F of x is 2 over x minus 2, so we know that denominator, x minus 2, can't be 0. So x cannot be 2. Now, remember, we're not putting x's into our f of x function. We're putting values of g of x. So the output's g of x. So we need to set g of x equal to 2 and solve for x. I'm going to say 2 equals the square root of x plus 4. We can solve that by squaring each side, and we'll get 4 equals x plus 4. We will subtract 4 from each side to get x by itself. And finally, we'll get x is 0, or 0 is x based on this. That's another restriction. So we know that x has to be greater than or equal to negative 4. And we also know, we found the domain of f of x, and we set that equal to g of x, and solved, and we found that x equals 0 is the restriction. So x cannot be equal to 0. So let's put that all together. We know that our domain of our composed function, f of g of x, is going to be all values of x, where x is greater than or equal to negative 4, and x is not equal to 0. We can also write that in interval notation. You can see we have a bracket, negative 4 comma 0, union 0 to infinity. So there you have it, our domain of our composed function. Now it's time for you to practice. So you'll see example 4 on your sheet. I want you to pause the video and try it on your own. Pause the video right now and then unpause it. Once you have it done, I'll reveal the answers. All right, if you've unpaused, that means you have done parts A and B. You can see here that f of g of x has a domain of all real x values except for 1 and 2. And then g of f of x has a domain of all real numbers excluding negative 3 and negative 5 over 2. All right, we have one last type of question, finding the components of a composite function. So if we have a function already put together, can we split it up or decompose it, we'll say. So we have f of g of x equals h if h of x is 3x squared minus 5 raised to the 21. When I'm looking at this function h of x, I see two things going on here. First, I see 3x squared minus 5. The next thing I see is that 3x squared minus 5 is being raised to the 21. So naturally, you can split this up into two functions. So why don't we say our inside function, or g of x, why don't we call that 3x squared minus 5? And our outside function, f of x, is something being raised to the 21. We can call that x to the 21. You can write it more simply as f of x equals x to the 21. When you have these functions where you're taking something apart to show what composition can make it, there's often more than one answer, but this is just one way that you can do it. Now there's 4 examples below on your paper. I'd like you to pause, try them, and then check and see how you did. Here are the 4 examples for you to try. Pause and try them. Then unpause and check your answers. Here are the answers for the last 4 examples that we have where you had to come up with f of x and g of x for a composition that makes h of x. Please let me know if you have any questions, and you're now prepared to go and do your homework for this section on MyLab. Have a nice day.